Right, so in this video, we shall be learning how to subtract fractions. And as normal, these videos are intended for students being tutored at Straw Success Tuition. The courses we tutoring, they are on the screen and the number to call is on the screen. So if you would like, you can call for further information. So let's review like terms. So if we were to have 4 apples and we subtract 2 apples, what would we have? 2 apples. If we had 4 trucks and we subtracted 2 trucks, we would have 2 trucks. Now, if we had 4 apples and we subtracted 2 trucks, we have no idea what we would have. So notice something important. We can only subtract like things. So apples with apples, trucks with trucks. We cannot subtract unlike things in a way that would combine them into a single term. And now, just as we can only subtract like things, we can only subtract like fractions. So that is fractions with the same denominator. For example, 4/6 subtract 2/6. So they are like fractions. Their denominators are the same. So this is similar to subtracting apples from apples. So we would have 2/6. However, if we were to have 4/6 and we're trying to subtract 2/5, this is like subtracting apples and trucks. They are different, they are unlike. So this subtraction cannot be done just like this. Now, the same way we could only subtract like fractions, we can only add like fractions. So bear that in mind. Another concept we must review is equivalent fractions. So equivalent fractions are different fractions that have the same value. And now, how could different fractions have the same value? Well, look at this comparison. So we have 3 persons here. One person have $100 bill, the next person has $250 bills, and this final person would have $420 and $210. So although the amount of bills each person has is different, what do we notice about the value? Yes, they all have the same value. So things could be, the same value could be represented in different formats. So let's see how it applies to fractions itself. So observe these circles, they have the same size. So let's see what fraction is shaded red. We have this circle here. It's divided into 2 equal parts. The one is shaded red. So we have 1/2 or a half. In this circle, it's divided into 4 equal parts. 2 are shaded red. So it's 2/4. And in this circle, it's divided into 6 equal parts. 3 are shaded red, so it's 3/6. So we notice the fractions may be different. 1/2, 2/4, 3/6. But we should recognize that the value, the actual amount of the circle that is shaded red is the same. So it's represented differently. The same value could be represented in different ways. So let's put them side by side and see, because just as we could have money represented in different ways, the same value, it's the same thing with the fraction. So with our 3 persons, the actual amount is the same, but how it is represented is different. One has $100 bill, another has $250 bills, another has $420 bills and $210 bills. But at the end of the day, the value is the same. Similarly with the fractions, this would be a half. This could be represented as 2/4, and it could also be represented as 3/6. The value is the same, although it is represented differently. So that is what equivalent fractions are. So let's try to subtract 3/4, subtract 2/3. They are unlike fractions, so it's like apples subtracting trucks. This cannot work. So we need to convert them. Once we have unlike fractions, we must convert them into like fractions. So how do we do this conversion? How would we convert unlike fractions to like fractions? Well, we find equivalent fractions that have the same denominator. But again, what number should we use as the denominator? Well, we can only use common multiples of all the denominators. Now, if we were to use the LCM of the denominators as the common denominator of the new fractions, we would not have to work with big numbers unnecessarily. So the LCM is sometimes better to use. And so now let's find the common multiples of these denominators here, 4 and 3. So we have 12, 24, 36. These are common multiples with these. So we could use any of these common multiples and convert these fractions into like fractions. Remember, it's equivalent fractions we are finding. So we want an equivalent fraction, something that is equivalent to 3/4. However, the denominator needs to be 12. So how do we move from 4 to 12? We multiply by 3. So if we multiply the denominator by 3, we must multiply the numerator by the same amount, 3. So that is 9 12s. So the value is the same here. 2/3 that multiply the 3 by 4 to get the 12. So we take the 2 and multiply by the 4, we get 8. 8 12s. So notice the value of the fractions are the same. The 9 12s and the 3/4, same value. 8 12s and 2/3, same value. So we could rewrite our question as such. Now notice we now have like fractions. Both fractions are 12s. The value of the original question is preserved. So let's do the subtraction. 8 minus 8 from 9, 8 from 9 is 1/12. And so even if we were not to use the LCM, we did not use the LCM, and we use another common multiple, we would still arrive at the same answer. We would only have to simplify more than if we had used the LCM, that's all. So let's use 24 instead of the 12. So how we move from 4 to 24, we multiply by 6. We take the 3, multiply it by 6. We have 18. Same thing with the 2/3. We take the 3, multiply by 8 to get 24. So we take the 2 and multiply by 8, we get 16. So again, the original fractions did not change in value. We found equivalent fractions. However, we found equivalent fractions that allowed us to turn them into like fractions. So we could rewrite our question as such. 18 over 24 subtract 16 over 24, we remain with 2 over 24. Now this has to be simplified. We cancel the common factor of 2. 2 into 2, 1. 2 into 24, 12. And what do you know? We have arrived at the same answer as previous. So it makes no difference. Even if we were to use 36, 48, and we go on with other common multiples, it will still be the same answer. We'll just have to simplify in the end. Now we could also cross multiply to find like denominator fractions. So if you have 3/4 and we are subtracting 2/3, let's do the cross multiplication. We would multiply the numerator of the first fraction by the denominator of the second fraction. So the first fraction is 3/4. That numerator is 3. It is going to be multiplied by the denominator of the second fraction, which is 2/3, and that denominator is 3. So 3 multiplied by 3, as you can see, would give us 9. Now the 9 is placed directly over the fraction that you multiplied, the numerator of the fraction that you multiplied, because we want to keep track of which fraction is equivalent to which. And now we'll take the next multiplication step. We multiply the numerator of the second fraction by the denominator of the first. So that will be this 2 multiplied by this 4. Again, we have 8. Final step is to multiply the denominator. Is 4 multiplied by 3 would give us 12. So pay attention to the new fractions we would have. Our new problem would be 9 12s minus 8 12s. Notice the 9 12s corresponds to the 3/4, and the 8 12s corresponds with the 2/3. So we have 1/12. Now, when we should not cross multiply? If one denominator is a multiple of the other, It is better not to cross multiply because you would be working with big numbers unnecessarily. For example, 1/2 subtract 3/8. Notice 8 is a multiple of 2. So notice we would work with bigger numbers if we were to cross multiply. So let's cross multiply and see. So 1 multiplied by 8 is 8. 2 multiplied by 3 is 6. 2 multiplied by 8 is 16. So our new problem would be 8/16 minus 6/16, which will give us 2/16. And we can see that this could be simplified. 2 into 2, 1. 2 into 16, 8. So we have a final answer of 1/8. Now, notice we would have worked with smaller numbers had we used the LCM. So the LCM here would be 8. So let's turn a half into 8. That would be 4/8 is a half. We don't need to do nothing with the 3/8 because it's already in the form of 8s. So our new problem would be 4/8 minus 3/8, which is 1/8. Clearly, we had no need to simplify, and we worked with smaller numbers. So that's the advantage of using the LCM. We would work with smaller numbers. However, the answer at the end of the day would remain the same once we follow the steps and work our questions properly. Now, if we are able to spot the LCM easily, there may be no need to cross multiply. So with 1/4 minus 1/6, we can see that the LCM here is 12. We can see that easily. Now notice what type of numbers we'll get when we just cross multiply. So 1 by 6 is 6. 4 by 1 is 4. 6 by 4 is 24. So our new problem becomes 6/24, subtract 4/24, we remain with 2/24. This could be simplified. 2 into 2, 1. 2 into 24, 12. So we have 1/12. Now, when we use the LCM, we would have smaller numbers. So 1/4 is the same as 3/12. And 1/6 will be the same as 2/12. So this new problem would be 3/12 minus 2/12 is 1/12. So if you notice, we had to work with 24ths. Now we just worked with 12ths. So the numbers would have been smaller had we done the LCM method. Now it is impossible for us to do this cross multiplication method if we have to subtract more than 2 fractions. Let's take this for an example. 5/6 minus 1/4 minus 1/3. So let's try to cross multiply. Let's cross multiply here. We have 5 by 4 is 20. 1 by 6 is 6. 6 4s are 24. So these new fractions would be 20/24 subtract 6/24. But we did nothing with the 1/3. So what do we do? Even if we were to cross multiply the third with another of these fractions, it still will not have all of the fractions with the same denominator. So again, we cannot do this cross multiplication when it's 3 fractions or more. Notice these two are like. Yes, these two are like. But this one spoils it. Good. So in a case like this, we need to find a common multiple of all. So let's try using the LCM. So we see the LCM is 12. So let's turn 5/6 into 12s. That will be 10/12s. Turn 1/4 into 12s. That will be 3/12s. And let's turn 1/3 into 12s. That will be 4/12s. So our new problem would be 10/12s minus 3/12s minus 4/12s. When we do this subtraction, we get 3/12. Now this could clearly be simplified. So 3 into 12, 4. 3 into 3, 1. Final answer is 1/4 or 1/4. So you pause the video and you give this question a try. Pause the video. When you are finished working out the question, start the video again and we'll do the solution. So pause it now. Great. So now let's try the LCM method first. So the LCM for these two fractions, denominator 7 and 5 is 35. So let's convert. We would have 4 sevens as 20/35, and we'll have 2/5 being converted into 14/35. So this would be our new question. 20/35 subtract 14/35. We have 6 all over 35. So that's our final answer here. We could also cross multiply. In this case, it will lead us to the same results. So 4 by 5 is 20, 7 by 2 is 14, 7 by 5 is 35. 20 over 35 minus 14 over 35 gives us 6 over 35. So in this case, cross multiplying and LCM turned out to be the same. It's not always like this, but we are happy when it is like this. So pause the video now and give this one a try. When you finish working it, restart the video, play the video again, and we'll solve it. Great. So let's solve this here. So LCM method, we see the LCM for these fractions would be 20. So 4/5 in terms of 20ths would be 16 over 20. A half would be 10 over 20. And a quarter would work out to be 5 over 20. So our new problem would be 16 20ths minus 10 20ths minus 5 20ths. And what would that simplify to? 1 20th. So we have our final answer here. And now sometimes we may not be able to spot what is the LCM. So we could just multiply the denominators and that would give us a common multiple. However, we would have to simplify after, right? But sometimes it's just more convenient to just multiply the denominators to figure out a common multiple and work our way from that point. So we have, in this case, it will be 40. 5 by 2 by 4 is 40. So turn in 4/5 as something with 40 as the denominator, an equivalent fraction, that will be 32 over 40. A half would be 20 over 40. And a quarter would be 10 over 40. So notice the value of the fractions remain the same. So our new problem would be as such, 32 over 40 minus 20 over 40 minus 10 over 40. So we'd have 2 over 40. This needs to be simplified. 2 into 2, 2 into 40, sorry, 20, 2 into 2, 1. Again, the answer is the same, 1/20th. So we should be able to see that. The answer is the same here, 1 over 20, 1 over 20. In one instance, we worked with 20ths. In this instance, we worked with 40ths. However, the answer at the end is the same because we simplified afterwards. So now let's move on to subtracting mixed numbers. How do we do that? Well, there are several ways to subtract mixed numbers. First, we can convert the improper fractions into, sorry, we could convert the mixed numbers into improper fractions and then subtract as normal. However, we may end up with big numbers that we would have to work with, and we really try to avoid working with bigger numbers than is necessary. The other method is that we could subtract the whole numbers first and then subtract the fractions. However, we may need to do some regrouping to get our final answer. So let's try this one. You give it a try, pause the video and try. Nice, pause the video. Good, so let's try it now. So let's try converting to improper fractions. So as improper fractions, this would be our question, 15 over 4, subtract 4 over 3. Again, we need to convert them into like fractions. So 15 over 4 is 45 over 12, and 4 over 3 is the same as 16 over 12. So our new problem would be 45 over 12, subtract 16 over 12, which will give us 29 over 12. Secondary school students could leave their answers like this. However, you dear primary school students, sadly, you must convert into mixed numbers. So you get 2 and 5/12. So let's try subtracting the whole numbers first. We have 3 and 1 as whole numbers. So let's subtract the 3 from the 1, we'll get 2. And now an important thing to bear in mind is that this 2 is really coming here. This 2 is going with the 3/4. Right? This is really, when this 1 was subtracted from this here. So that is what you have remaining here. We are just keeping it at the side here to keep our workstation neat. We are ignoring this 2 for the time being. We are just ignoring it, but do not forget that it exists. It is still part of the question. So now let's convert these fractions here and then do the subtraction. So 3/4 would give us what? 9/12, and a third would give us 4/12. So this would be our new problem. 9/12 subtract 4/12. That gives us 5/12. However, remember our 2. Do not forget the 2. So we have a final answer of 2 and 5/12. Now, sometimes when we are subtracting, we just reviewing. Sometimes doing subtraction, we would have to regroup. So let's remember a question like this. Try this question, 46 subtract 19, and we would see when we have to regroup. So we are trying to take 9 from 6. That cannot work. So we go to the next number place and we take 1. So 4 becomes 3, and this 6 becomes 16. But if we took 1, why does it become 16 and not 7? Well, note, we did not simply take 1. We took a group of 10 because this 4 was in the tens place. This is actually 40. So we took one group of 10. So that is why we would have 6 plus the one group of 10, which is 16. That is why we have 16. So we do the subtraction. 9 from 16 would give us 7, and 1 from 3 would give us 27. So bear that in mind. When we are taking 1, we have to bear in mind what we are actually taking and how it affects the value of the question. So it's something similar when we are dealing with the fractions. So observe 3 1/4 minus 1 1/3. So let's convert to improper fractions first, and this is what we would have. Let's convert now into like fractions, and this is what we would have. So our new problem would be as such, and 23/12 convert into mixed numbers, 1 and 11/12. So once we convert into improper fractions first, we will not need to regroup, right? There will be no need to regroup. However, we may end up working with big numbers, which we try to avoid. So every method would have its advantage and disadvantage. So in this method, let's subtract the whole numbers first. So 3 subtract 1 is 2. Let's deal with the fractional parts now. And we are seeing we have a slight error here. So this is not 3/4. This is actually 1/4. Right? Good. So let's get this. Good. So let's convert 1/4. That will take us to 3/12, and 1/3 will carry us to 4/12. So our new problem would therefore be 3/12, which is the same as a quarter, and we are minusing a third, which is the same as 4/12. So what would that give us? Well, notice, sorry, we made a step, right? So let's go back. So we have the new problem, 3/12 minus 4/12. So here we have 4. We are trying to take 4 from 3, which cannot work. We cannot simply take 4 from 3. So what do we need to do? We need to go to our next number, please. So all the time we were ignoring this 2 here, but this is really 2 and 3/12. Right? So we are no longer ignoring that 2 because we need his help. So we'll take 1 from it. So notice we are taking 1 from that 2. And now how would we take this 1? Well, recall this is fractions. So 1 in this setup would actually be 12/12. So we have to add that to this. But this is too bulky to write, so we will not write it. We already know that the denominators are the same, 12s, 12s, 12s. We know that, so we could skip that out. And just put a plus 12 here, right? And we perform the subtraction. 3 plus 12 would give us 15 minus 4 is 11/12. Now, this is not the final answer because we must remember the 1. This 1 must be remembered in the whole number part here. Right? So we must remember that. So our final answer, as normal, is 1 and 11/12. So again, notice the answer is the same. the answer is the same. The difference is we did not work with big numbers. Here we work with a 39. We did not have to work with such big numbers in this instance.